Hello my dear students, welcome in maths class, and in this class, in this video I am going to discuss sum of first n terms of an arithmetic progression. So we will discuss how this formula is derived, how we will derive this formula, and after that where we will apply this formula. So let us suppose an example of counting numbers from 1 to 100, and if I have to add the numbers like this way, 1 plus 2 plus 3 plus 4 plus so on so up to 100, and if manually we will do its calculation like 1 plus 2 3, 3 plus 3 6, 6 plus 4 10 plus 5 15, then so on so up to 100 we have to add these numbers, then it is very time consuming process. It is very time taking. In the same way, if I have to add the numbers like 1 plus 2 plus 3 plus so on so plus 1000, if manually we will do this calculation, it is very time consuming process. So for this I am going to derive this formula, and with the help of formula we will solve these calculations at the end of this one. So first let us derive this formula. So here Sn means sum of first n terms. A is very first term, a plus d it is second term, a plus 2d it is third term, and in the same way a plus n minus 1 it is the last term, and second last term is n minus 1 minus 1. So minus 1 and minus 1 will be the minus 2. So second last term will be the a plus n minus 2 into d. So again I am saying Sn means sum of first n terms, and this is general term, first term, second term, third term, so on so second last term, and this is the last term of arithmetic progression. Now in the second line we will write all the terms in reverse order. Again I am saying we will write all the terms in the reverse order in the second line. Write this last term under this first term, that is a plus n minus 1 into d, then second last term plus so on so, third term, second term, then first term. In the first line you see there are n number of terms, and we have written these n number of terms in the reverse order. Now we will add first term to the first term, second term to the second term, third to the third term, last term to the last term, first term here, and second last term to the second term. We will add like this way. So a plus a, it is coming here 2a plus n minus 1 into d. In the same way here, when the second term added to the second terms, it is coming a plus a, it is 2a plus n minus 2. This is n minus 2 into d plus 1d. So n minus 2 plus 1 d, I am taking it is common. So when I will solve, it is coming n minus 1 into d. So it is again coming 2a plus n minus 1 into d. In the same way, last term added to the last term. So a plus a, it is coming 2a plus n minus 1 into d. Second term added to the second one, second last term. So it is coming second last to the second last. So it is coming a plus a, 2a, and d, and it is n minus 2. So when we will add these two, it is coming n minus 1 into d. Now n terms added to the corresponding term. So in the resultant here, we have again n number of terms. So 2a plus n minus 1 into d, 2a plus n minus 1 into d. In the so on, this term is coming here n times. So if we are adding 1 plus 1 plus 1 plus 1 plus 1 5 times, 1, 2, 3, 4, 5. So my answer is coming 5. 5 into 1. So my answer is 5 here. In the same way, these 2a plus n minus 1 into d, 2a plus n minus 1 into d, it is coming n number of times. So when we will add all these terms, so whatever is coming here, I am writing it is n times of 2a plus n minus 1 into d, because it is coming n number of times here. Again I am saying in the first line there are n terms, and we are adding in the corresponding term. So in the resultant again there are n number of terms. So this side it is 2 times of Sn. And now 2 I am shifting to the right side. It is n by 2, 2a plus n minus 1 into d. This is the formula of sum of n terms of an arithmetic progression, where Sn denotes the sum of n numbers, n is number of terms, a is first term, and d is the common difference of that arithmetic progression. Now, after this, I am going to derive one more formula. So here, Sn is equal to, I am writing here, Sn is equal to n by 2, 2a plus n minus 1 into d. This is the formula of sum of first n terms of an arithmetic progression. Sn is equal to n by 2. This 2a I am writing like this way, a plus n minus 1 into d. This second term a we will combine with n minus 1 into d. So I am using a curly bracket. If you will see, it is Sn is equal to n by 2 a plus, and this is equal to the nth term of an arithmetic progression, that is a plus n minus 1 into d, that is an, and we can write that an is equal to n by 2 a plus l. So here n is number of terms, a is very first term, and l is the last term of that arithmetic progression. So this formula we will use when its first and last term will be given to us. And in general, the sum of n terms of an arithmetic progression formula is n by 2, 2a plus n minus 1 into d. Now I am taking the two examples where we will apply these sum of n terms of an AP. I have an example of, suppose, 1 plus 2 plus 3 plus 4, so on, so 100. If manually we will do this calculation, it is a very time consuming process. But if see, 1 plus 1 is 2 plus 1 3, it is an arithmetic progression, and in this AP the very first term is 1 and last term is 100, and from 1 to 100 number of terms are 100. So with the help of this formula we can find its answer very easily. So number of terms are here 100, so we can write it is as 100. This is equal to n by 2. So in place of n we can write it is 100 by 2. First term is 1 and last term is 100. So this answer is 100 upon 2 into 101. So after calculating, we can find, I am underlining this one because I have to use it. So 2 and 50 will cancel, and after solving its answer is coming 5050. So this is the sum of all the numbers from 1 to 100. In this way, I am taking one more example of, this is first example, then another example of 1 plus 2 plus 3 plus so on so plus 1000. We have to find the sum of numbers, natural numbers from 1 to 1000. So here first term is a is 1, last term is here 1000, that is L. So Sn is equal to n by 2 a plus L. This formula is applicable here. So number of terms from 1 to 1000 are 1000 upon 2. First term is 1 and last term is 1000. So 1000 upon 2 into 1001. So if you generalize this one, these two terms, this is as 1000. If we will generalize these two, if I am finding the sum of 100 terms, it is coming 100 plus 1, 100 into 100 plus 1. If I am calculating the sum of first 1000 term, it is coming 1000, then 1001 upon 2. So if we have to generalize this one, and after this I can write one formula that is called sum of first n natural numbers, and this formula is Sn is equal to n into n plus 1 whole divided by 2. If suppose I am taking first 1000 number, so it is coming 1000, 1000 plus 1, 1001 upon 2. If I am taking here first 50 numbers, so 50 into 51 upon 2. So with the help of this formula, we can very easily find the sum of first and natural numbers. So that's all for this video. Thank you very much.